I'm Tong from TU Delft. Today I'm going to present mainly the work from Timon, and the co-authors are Ranjith and Sander together with me. So as you can see on the right side, we see that, for example, the poor verification, if not all requirements are verified, it would cause delays and also penalties and very costly for repairs. So we think that we should try to make the manual method of time-consuming and error-prone verification process be more automated. And this project is focusing on the process requirements. What we mean with process requirements is the requirements for quality management, scope management, information sharing, those type of textual requirements, so not technical requirements. In order to further understand the problem, we used a business process modeling approach to understand the current process. I'm not going to go detail in this, but we highlighted 3 parts that could be automated. For example, you can see very clearly, well, maybe not very clearly, those are all the manual checks with all the requirements, whether these requirements have been fulfilled or not. So from the scientific literature, we also see if we want to use AI for traceability, there are several challenges. For example, the explainability, the black box part, and also the data dependency. So we don't have large data sets to train our model, so we want to use a general purpose large language model to see whether it would work. And then also regarding the AI Act and the limited adoption and usability of the existing tools. So the main research goal is to explore whether we can use general purpose large language models in combination with a knowledge graph to create an automated process requirements verification artifact focusing on the process requirements in order to tackle the challenges such as the explainability, transparency, and accountability. How we did this? We followed the design science research methodology, which you can see we already identified a problem based on the specific tasks performed by each actor involved. We also design accordingly the solution requirements, and then we do the iterative process to design and evaluate the artifact we developed, and then discuss the implications. So based on the interviews we did, several requirements for the solution have been listed here. As you can see, what should the system do and what the performance and usability we want to focus on. I'm going to come back to this later. And this is the iterative process about the design, demonstrate, evaluate, and this is we use the classification performance matrix to see whether each iteration fulfills the requirements that we have set in advance. So for the design part, we use a general purpose large language model, specifically GPT-5 in Copilot. We use RASE markup language to extract the requirements so that they are structured. And then for the requirement document, we use large language models to create this RDF-based T-box, so what is expected from the client. And then for the contractor document, which we think are the evidence to show that we fulfill the requirements from the client, which the large language models generate an A-box assertions, which are basically the evidence to link with the requirements. To give an example of the original requirement text, as you can see here, the project management system, including the underlying processes, should be based on certain standards using an accredited organization, and the extracted requirement text from the contractor document that they use PMS and processes are based on a quality management system certified by an institution according to certain standards. So we see that this requirement is fulfilled by the contractor and provided in their document. We have done 4 iterations, and then each iteration generates a knowledge graph linking the requirement and also the evidence from the other documents provided by the contractor. As you can see, through the iterations, more links are generated. And here you see the detailed results on the right lower side. As you can see that we set the requirements for each performance matrix above 0.9 And in iteration 4, we reached that threshold. So we consider this as the good artifact to be tested with the users. And to go through this, so what we did actually 4 prompts. The first prompt asked the Copilot to generate the RDF T-box from the requirement documents. And then on the right side, we also asked large language models to generate the A-box, the evidence assertions. Of course, with specific requirements like the confidence level should be included. Also, be specific about where it comes from, which page, which chapter. But of course, in between, we add prompt 2, which is about to fine-tune the language models, because we want the language model to remember what the previous iteration has generated so that it doesn't forget. And then both these RDF files are imported to the graph database, in which we use another prompt to structure a dashboard. And you can see with the dashboard, the users can intuitively interact with what requirements have been met and what has been missing. And then this is a very specific example where you can see that requirement 4 comes from chapter 2.5, and the page number is not available, but the quotation is also there. It's grayed out for confidentiality, and also the confidence values, to what extent this is the system is confident about this link. And then we evaluate the last iterative artifact with the focus group. There are certain positive aspects, like they think this is very practical and also save their time. In average, it's 5.3 minutes. And then even just the left side of the pipeline, just to extract the requirement, is already very helpful according to them. And there's no fear for legal complexity because the contract is leading. However, we do see potential enhancements like full automation. And of course, if you can add more domain knowledge, like labeled data set, that would be better. And of course, for usability, we did a specific test with them based on a questionnaire. As you can see here, that the SUS number is quite okay, meaning that they think this is quite useful. But the NPS value is passive, meaning that they wouldn't recommend it yet to the other users, but they do think that that the usability is good. And certain reflections, as you can see, we talk about functional and non-functional requirements, and certain things are fulfilled and certain things are not. Specifically for reliability, there are 2 false negative links being identified, which we think that should be further dived into to find out the reasons. And then the interoperability of the artifact, because now it is currently mainly based on Copilot. Limitations, as I mentioned, we think that the false negative might be caused by the T-box to A-box leakage. So meaning that maybe because of the inheritance of the T-box, so there might be some wrongly labeled concepts. And yeah, so these are some practical contributions. We do see that the time is reduced, and it's also a promising approach for automatic verification, both for contractors and also for the client. And then we recommend certain with human in the loop or not with human in the loop, how we can further develop the system, like with RAC and those type of things. And then how we can incorporate the learning in the loop process as well for the client. Yeah, here we address the explainability by generating the knowledge graph, so you can easily see the links, and also how we can try to improve the usability by generating this dashboard. And then the data dependency, so we use general purpose language models with no large data set needed. And these are the practical steps that we recommend to take for the company to go forward. Yes, I think I'm running out of time, so you can read a concluding part yourself. Thank you for your attention.